Hello and welcome to Chicory's maintenance series. This time we're working on the engine mounts. And I think I told you in our most recent video, once I finished the reduction gear installation, that I didn't want to hook up the coupler for the transmission to the shaft because I was going to be messing around with the engine. So I'm just going to tell you what I'm planning on doing, and then I'll show you, and it'll be interesting to see how close what I'm planning to do is actually what I do. So there's a couple things that I'm doing here that are slightly unusual, and I'll explain why. So here is the mount that goes to the engine, and here is the existing mount. Here is the replacement mount that I'm doing, which is actually factory. You can see the one that's here is not factory. So instead of just removing the mount and putting this in, I am going to remove this whole frame assembly that mounts the engine, mounts to the engine and to the mount and supports everything. The reason I'm doing this is you can see this Allen bolt right there. And if Tracy zooms in on this, it's pretty kind of hard to see, I guess. But this is a very unusual bolt. The reason that it's unusual is that the 46 Nordhavens were built in Taiwan. And as I understand, and this is supposition, but I believe it to be true, that at the time at least, the Taiwanese culture was very superstitious. And they took that superstition far enough that a normal United States SAE bolt that's 1/2 inch has 13 threads per inch. And they believed that that 13 was unlucky, so they bolted my engine mounts to the beds with 1/2 inch 12 thread per inch. Now these bolts are very difficult to find, and that's why I have this bag there of spares. But what I've been planning to do all along is to use a helicoil kit, drill out those holes, re-tap it with a helicoil tap, and then do thread insert helicoils so that I can use standard 1/2 inch 13 threads per inch bolts. The reason that's important is it is highly recommended that engine mount bolts are grade 8 or higher. Not only are the 12 thread per inch bolts difficult to find, but they're particularly hard to find in grade 8 or higher. So this is one of the reasons I'm going through this process of removing this frame so that I can get access where I can drill down into the engine bed. And I believe that fiberglass in here is either an aluminum or a steel plate that I'll be drilling, tapping, helicoiling, and then eventually mounting to. And you can see why I need to remove this part of the mount so that I can get a drill and tap and do everything, because right now with this in the way, it'd be virtually impossible. So my first step that I'm going to do is I'm going to use the hydraulic ram that you saw me use if you watched the video on changing the cutlass bearing. And I'm going to take out these bolts on this just one mount. I'm going to put the hydraulic ram underneath the engine. I'm going to lift it up, and then I have cut probably 10 each of these. I have a 2x4, a 2x3/4, and by 1/4 inch. And by using a combination of these, and I also have some plastic shims, I'm going to jack up just probably like a 1/16 or an 1/8 of an inch, just enough to give me some clearance so that the engine weight is not on the bolts on this frame assembly. I'll shim it up, drop the weight back down so it's supported on this, then remove this mount. The engine mount will still be bolted to it. I can then install this mount on the frame member at the exact height that this is. And so when I reinstall it, it should virtually be in the same position. I'll do that one at a time to the 4 mounts. And my supposition is that because everything will be so close, that my engine alignment process should be relatively straightforward, because I'm not removing the whole engine, jacking it up, changing all the mounts, and dropping it back down. I should have better reference. So the next step you'll see is I'll be jacking up the engine, and I'll be back in 1 minute. Thanks. Okay, I'm back, and you're looking underneath the engine. You can see there's 4 2x4s, and they're on the bilge of the engine. And then I have a little scissors hydraulic ram that I have put in between those supports and the bottom of the bell housing. You can see that I'm only on like a 1/2 inch of that. So what I'm going to do is slide my other shims and small pieces of wood to take up that space, so that if that hydraulic component fails, that it won't let a lot of that slack out. And let me show you where we are now here with the engine mount. So you can see that the shim easily slides in and out. I've got, I don't know, maybe 1/16 or 1/8 of an inch there. So obviously the bolts that you can see at my fingertip right there and there's 4 of those in total that are holding that frame member on. They're very difficult to see because they're super tight clearance. So I'm going to shim the engine first, and then I'm going to start working on those bolts, and I will be back to you very soon. Thanks. Okay, so I have utilized offset box end wrenches, ratcheting box end wrenches, swivel impact wrench, multiple extensions, all because you can see how much clearance there is. The thing you can't see on the back side is there even less clearance. So I removed the 4 bolts. The last time you saw that I had removed this. So I'm now ready to break it loose. Oh, there we go.
Wow.
So
Unexpected.
there is a shim plate here, and I'll measure that to see if we need a thicker one or if we need to put one back in place. But essentially what they were doing is they were trying to minimize the distance. But what I'm going to do is calculate with the new mount, and I'll show you when I get upstairs.
Tip it at an angle a little bit. There we go.
So I'm going to measure for the distance from here to here precisely on each side, and I'm going to pull this off and put the new mount on and keep that distance absolutely perfectly. And I'll show you that in just a minute, but I'm going to get out of the engine room right now and start addressing that. But I'll have Tracy show you one more time. So the engine is supported by the hydraulic ram. I also have the shims there. So I'm going to clean up this stuff, change this over, but this seems to be working pretty well so far. I'll be back in a minute. Okay, I'm back, and I have the frame member and the mount out, and I'm making my measurements. I'm using a digital caliper, and Tracy's going to face down on this, and I'm going to show you a couple things. So you'll notice that the distance here are different, and I measured them, and they're 186 thousandths is the farthest out they are from this corner to this corner up, and that is pretty close to equal to 3/16 of an inch. Now, the insulation should be where the bottom of the mount and the bottom of the frame member are parallel. And Tracy's going to go down and look at the bottom. You'll also notice that this surface and this surface are not parallel. Once again, ideally, the way the mount is designed for thrust, these 2 surfaces should be parallel. So these are the things that I'm working on right now. So Tracy, why don't you show them this as well? So this is the shim that was underneath here to raise the mount up, and this shim you can see is corroded. Even though it's aluminum, you know, it has a bunch of oxide on it, and it is 6 thousandths out of parallel as well. So that exacerbated the issue with this. So one of the things that I'm going to do, I'm going to switch this sideways so Tracy can see. If I were to take the new mount right now, so if I put both mounts at the same location, you'll notice that the spindle of the mount is towards the top end. And one of the things while I'm doing surveys, I see this a lot. The mount manufacturer really wants the engine frame member to be around the center of this rod so that you have adjustment down and up. And the farther you go up towards the top, the more stress that the engine can impart on this rubber part. So I really want this taller. So what I'm going to do is I'm going to replace this aluminum shim with a fiberglass shim that will move this mount up, and it will give me the opportunity to grind part of the material to make this surface parallel to the engine frame member and align everything the way it should be. Now I'm going to check to see if part of this misalignment we just talked about is a result of this motor mount failing, or if this surface on the engine frame member is not parallel to my engine bed that's in fiberglassed into the hull. So what I'm going to do is I'm going to disassemble this now that I have my measurements. I'm going to re-bolt the member on, and I'm going to measure from the member bottom edge to the engine bed, and I'm going to see if the measurements are equal to this, or maybe it's just the mount, and I'll be back telling you what happened with that. Okay, I'm back in the engine room, and one of the things that I discovered is with the bolts in and loose, the engine frame member can move quite a bit. So one of the things that I was trying to figure out was it this position that was giving me that 186 thousandths of difference between the front edge and the back edge? So I was using my digital caliper, and I was doing this, so you can see I have it referenced to the bottom edge, and I was checking all four corners of where the mount will hit, and you can see the front edge is very parallel. The back edge is very parallel as well. However, if I adjust this to the back edge and I get it to the same level, I gotta loosen my little screw here. I'm going to bring this even at the back, and I'm going to tighten down the set screw. And I don't know if you'll be able to see this. Probably not. But anyway, it's about that 180 thousandths that we were talking about. So I will have to put in a shim here and grind it, and I will get back to you in a second and kind of show you what that's going to look like. I'll be back. Okay, so I'm out of the engine room, and I made a little mock-up here. If Tracy can come down and look straight in. So what I'm showing here is this was the old level of where the mount was, and you can see I'm pretty close to mocking this up. But what I'm doing in the future is I'm going to get 3/4 inch of fiberglass, which this is represented with these three boards. They're all 1/4 inch. I'm going to buy a 1/2 inch and a 1/4 inch because I can't buy 3/4 inch. One of the reasons that I'm doing this is the black area here I have colored. That is the area I need to grind away because the engine bed, which is represented by this black mat, is not parallel to this surface. So I need to grind this material away so that this surface here and this surface here will be parallel. And I'm going to ask Tracy to zoom in on this so you can kind of see what happened in the past. You can see that there's a big space here between the mounts bolt and the nylon bushing, and then on the other side it's pushed really hard against the frame. So what was happening here is this bolt is actually supposed to be centered, and it is not supposed to push vibration into this outside metal mount. it's supposed to be pushing it down to the inside where this is filled with rubber. So this mount was definitely transmitting quite a bit of vibration and probably fatiguing this over time. So this will be a much better setup, but at this point in time I need to order from Master Car the materials that I need. I'm going to order a 1/2 inch thick material, 12 inch by 12 inch. That'll give me enough to get obviously 4 6x6 pieces out of, which is way larger than I need, but 12 by 12 is the smallest size I can buy. And then I'll do the same thing with a 1/4, and that'll give me flexibility for all 4 sides. But I need to wait until I do the next step for that fiberglass. So I'm going to end the video now, and thank you for liking, subscribing, viewing, and commenting. I really appreciate it, and next week I can show you, or the next video I can show you drilling, tapping, and helicoiling the engine beds, and hopefully showing you grinding the fiberglass and doing my first engine mount. That's the plan, at least. So until next week, thanks for hanging in.